Hello friends, I'm Jonati Ghosh and welcome to my video series on exploring mathematics using spreadsheet. In every session of this series, we explore a very interesting mathematical problem using the spreadsheet MS Excel. Okay, so let's get started and I'll be sharing my screen. So, as I said, we are going to explore a very interesting problem, and today's problem is a very popular one called the spaghetti problem, and it's one of my favorites. You might be wondering what can be so problematic about spaghetti. Well, it can lead to some very interesting explorations. So what does the problem say? The problem says that let us assume that there is a spaghetti stick and we are able to randomly break the stick, say of length L, into three parts. What is the probability that the three parts will form a triangle? So let us assume that this blue line represents a spaghetti stick of length L units and it is broken into three parts. And when we try to put the parts together edge to form a triangle, we can check. In this case, probably it is forming a triangle. But there may be cases where the three parts do not form a triangle. So the question is asking, what is the probability that these three pieces or parts will form a triangle? So that is the problem. Okay, so let us analyze this, and we are going to do a little graphical analysis of the problem. So let us say this is our spaghetti stick and these black lines indicate the points where the stick is broken. So this leads us to three pieces, one of length, let us say of length X, the other of length Y, and the third piece will be of length L minus X minus Y. Now, under what conditions will these three pieces form a triangle? So you must be well familiar from your school days of the triangle inequality. So what does the triangle inequality tell us? The triangle inequality tells us that three lengths will actually form a triangle, three line segments will actually form a triangle if the sum of any two of them is greater than the third. So if we apply that condition, then one condition we arrive at is that x plus y should be strictly greater than L minus x minus y. This could be one condition. Another condition is the sum of x and L minus x minus y is strictly greater than y. And the third could be y plus L minus x minus y is strictly greater than x. And this leads us to, these inequations can be simplified. And let's say the first inequation leads us to the fact that 2x plus 2y is strictly greater than L. So x plus y is strictly greater than L upon 2. The second inequation, we can cancel x and minus x, and we get L is strictly greater than 2y, or y is strictly less than L upon 2. And similarly, the third one, we can cancel the x, y and the minus y, and this will lead us to x is strictly less than L upon 2. What are x and y? They are lengths of parts of the spaghetti stick. So definitely x and y should be greater than 0, otherwise we will not have these parts. Now we have these three inequations and x plus y is also strictly greater than 0. So we can plot them on the two-dimensional plane. And what we get is an interesting scenario like this, where let us assume this is the x-axis, it represents all the parts of length x. The y-axis represents all the parts of length y. And let us notice some of the points on this. So let this point be L comma 0 and this be 0 comma L. So if I join this line, the equation of this line will be x plus y equal to N. Similarly, this point is L by 2 comma 0 and this point is 0 comma L by 2. So if I join these 2 points, I get the line x plus y equal to L by 2. And this line parallel to the x-axis is y equal to L by 2 because it passes through 0 comma L by 2. And this line parallel to the y-axis passes through L by 2 comma 0, and therefore its equation is x equal to L by 2. Now, what does this equation, the inequation indicate? X plus y strictly greater than L by 2 would be the portion of the plane, so x plus y equal to L by 2 divides the plane into two halves. And this half would be x plus y strictly greater than L by 2. Coming to y less than L by 2, this is the line y equal to L by 2. So anything below this line will be represent y less than L by 2. And x equal to L by 2 is this line, so x less than L by 2 would represent all the points on this side of the line. And of course, since x and y are strictly greater than 0, we are in the first quadrant. So which is the portion common to all these three equations? It would be all the points, the portion or the region lying in this triangle. So every time you break a spaghetti stick, you generate a point, you generate an x and a y. And the moment you plot, you point, you can plot that on this first quadrant. And every time you break a stick, you get a point in this, inside this bigger triangle. So the bigger triangle gives us all possible cases. I mean, that is, of course, if you break a sufficiently large number of spaghetti sticks. And the points which lie inside the smaller triangle represent those cases where a triangle is formed. The triangle is formed. So the area of this triangle upon the area of the bigger triangle will give us the classical probability. So what is the area of the bigger triangle? The bigger triangle, it has base of length L units and a height of length L units. So half base into height gives us the area as L square by 2. And the area of the smaller triangle, which has a base of L by 2 units and also a height of L by 2 units, and half into that will give L square upon 8. So L square upon 8 divided by L square upon 2 gives us the probability, the classical probability that a randomly broken spaghetti stick into three parts will actually form a triangle is L square upon 8 divided by L square upon 2, which is 1 upon 4. So I hope you found this analysis interesting. This is the classical probability, 1 upon 4. So now, another way to interpret this problem is a 3D visualization of this problem, where you imagine that the lengths of the three pieces are x, y, and z. So suppose again, this is the spaghetti stick broken in two parts, and let the three pieces now, the piece lengths be x, y, and z. So of course, x plus y plus z is equal to L. So what does this represent? X plus y plus z equal to L actually represents a plane in 3 dimensions. And we will plot we will use a software called Geogebra to plot the intersection of this plane in the first octant where x, y, and z are greater than or equal to 0. Then we will plot the three planes. Now note that the inequations which will lead to triangles are these: x plus y is strictly greater than z, or x plus z strictly greater than y, and x plus y, y plus z strictly greater than x. Now these are the three inequations we want. So we plot the planes x plus y equal to z, x plus z equal to y, and y plus z equal to x, and their lines of intersection with the plane x plus y plus z equal to L. And let us see what happens. So this is just a screenshot of what appeared on Geogebra. So this pink triangle represents the intersection of the plane x plus y plus z equal to L in the first octant. And these blue lines are the points of intersections of the three mentioned planes. And this blue triangle represents those cases where the three parts of the spaghetti sticks will actually form a triangle, and the pink triangle gives all possible cases. So let me take you to the Geogebra. And so here you can actually see it in a 3D visualization. You can see that this black triangle in the first octant is actually the intersection of the plane x plus y plus z equal to L. Here I've taken L to be 4 units in the first octant. And this black triangle represents all possible cases of broken spaghetti sticks. Now when we take the plane x plus y minus z equal to 0 and its intersection with the x-axis, its intersection with this x plus y plus z equal to L, we get this blue line. Similarly, if we take the plane x minus y equal to z equal to 0 and its intersection with the same plane, we get another line. And finally, if I take the third plane minus x plus y plus z equal to 0 and its intersection with the plane x plus y plus z equal to 4, I get a third line. And all these three lines lead to this brown triangle whose area we see is exactly 1/4 of the bigger triangle. So this is another way of actually visualizing the problem. Okay, so now we come back to the real essence of this video session is where we want to use the spreadsheet Excel to simulate the spaghetti problem. Here, let us assume that the length of the stick is 100 units. Suppose this is the spaghetti stick again with the breaks at these points. Let the three parts be of lengths A, B, and C. So we want Excel to simulate the lengths A, B, and C. We generate two random numbers X and Y, which will denote the breaks, the points where the stick has been broken. And this can be done by using the rand between command 1, 100, and we will place them in the cells B2 and C2. And these will represent the numbers X and Y. Now, if B2 is less than C2, so we'll use the conditional statement that if B2 is less than C2, then A, the part A should have the value, the smaller of these two values, that is B2, else it should have C2. So we will use a series of conditional statements to simulate the lengths A, B, and finally C will be 100 minus the sum of A plus B. So we will use these conditional statements to simulate the three lengths A, B, and C. And finally, how will we check that A, B, and C actually form a triangle? For that, we need to check the maximum value of A, B, and C. If it is less than 50, then a triangle will be formed. Otherwise, a triangle will not be formed. Now, suppose we simulate a large number of these. So let's say we have 100 simulations of broken spaghetti sticks. In each case, we will get an A, B, and C, and we have to check whether these three form a triangle or not. So we can count the yeses will indicate the cases where a triangle has been formed, and we can count the number of yeses. So let me take you to the Excel sheet. I hope you can see it clearly. So I have a serial number column in which I enter 1 equal to, and I will use the fill series command to generate a column from 1 to 100, and so we have a column from 1 to 100, and now to simulate the first breaking point, I will use the rand between command 1, 100, and I can drag the same thing to Y. So note that X has value 57 and Y has value 35. So these are the randomly generated breaking points of the spaghetti stick. Now suppose I double click here, I will get all possible values of X, and I'll get all, if I double click here, I'll get all possible values of Y. Each row will represent one spaghetti stick. So let's take the first case. Now, what will be A? So the condition that will help us simulate A, the length of A, says if B2 is less than C2, then output should be B2, else it should be C2. So this should help us simulate the piece of length A. Now notice this. In the first simulation, we are saying that X is 45 units and Y is 7. So the smaller value has gone to A. And now I'm going to simulate the length B using that condition. If B2 is less than C2, then the length of B should be C2 minus B2, else it should be B2 minus C2. I hope I've got that correctly. And press enter. Now let us look at this. So X value is 41, Y value is 69, the smaller value, the A is 41, and the difference between 69 and 41 is the length of B. And finally, I want to simulate the length C, which will be 100 minus the sum of A and B. So I do that. Once again, let us check. Oh, so let's look at this case, interesting case where X is 1 and Y is 2. So the smaller value, A gets the smaller of the two values, B gets the difference of these two values, and C gets the balance from 100. Now, how do we check whether it actually forms a triangle? We will check if the maximum value of A, B, and C, if the maximum, I should use the maximum command, if the maximum value of A, B, and C is strictly less than 50, then the output should be yes, else it should be no. That is only if the maximum value of these lengths is less than 50, that is the half the length of the stick, then only a triangle will be formed, else it will not be formed with a C. Now here the piece lengths are A is 55, B is 1, and C is 44. The maximum value is not less than 50, and therefore a triangle is not formed. So now I can select all these and simulate. So I get a lot of yeses and nos, and my actual empirical probability will be, I need to count. So I use the count if command. I need to count how many yeses are there in this column G. So I'll say count if, let's say G1, G2, sorry, to G2 to G101. I need to look for the yeses. How many yeses are there? And divide it by 100. See if this works. And you see that the probability is 0.28 for this set of 100 simulations. Now, if I just double click on this anywhere on the sheet, I will get a new set of 100 simulations, and now the probability is 0.23. So do keep seeing how the probability is changing. Now it's 0.35, whereas the classical probability is 0.25. So if you keep doing this, you will get different values of the probability, and these are empirical probabilities. So they'll not be exactly 0.25, but they will be somewhere around that. What happens if I do 1,000 simulations instead of 100 simulations? So for that, what I can do is I can go back to this cell and I can generate a column of 1,000 numbers. So say 1 to 1,000. So instead of simulating only 100, suppose I simulate 1,000 broken spaghetti sticks. Well, now I can come down and maybe I can select all these and double click. So the entire sheet has now 1,000 simulations. If you go down, you can see that 1,000 simulations. But I need to modify this and check that if counted from G2 to G1001 and you divide by 1,000, now the total number of simulations is 1,000. So here we get 0.227. Now if I double click on this sheet, I will get another 1,000 simulations whose probability is 0.229. Do it once again and we get 0.244, which is very close to 0.25. So as you keep on increasing the number of simulations, your probability, empirical probability, will give you a better approximation of the theoretical probability of 1/4. So this is a very interesting problem, and simple conditional statements allow us to simulate it on Excel. And now coming back to the problem, there's some interesting extensions of this problem. So one interesting thing is to take the case of n equal to 4. That is, if a stick is broken into 4 parts instead of 3, then what is the probability that they will form a quadrilateral? So in fact, the probability happens to be half. And one can try to create a spreadsheet simulation for this. So the same simulation that you just saw, you can extend it to now a case of 4 pieces A, B, C, and D. And the generalized problem says that let us assume that we are able to randomly break a spaghetti stick of length L into n parts. So what is the probability that these n pieces will form an n-sided polygon? So this is also a very interesting problem for exploration, and maybe we will analyze this on another video session. I do hope you enjoyed this problem, and there are a plethora of problems, interesting problems in probability which can be simulated on MS Excel, and I hope you will keep looking at my video series to enjoy these problems. So thank you very much for a patient listening. See you again soon. Bye-bye.